Welcome, Level 2 Physics, to a new topic, electromagnetism. We're going to be starting with static electricity. So, static electricity is also known as electrostatics. It is involving charge which is stationary and not moving. And we're going to be looking at various things. We're going to be looking at Van de Graaff generators, which you may have used in earlier years. Rubbing balloons and why they stick to your hair, rubbing cones and why they attract pieces of paper, lightning, photocopying, laser printing, and finally the application of electrostatic spray painting. So, in order to understand the concepts of static electricity, we've got to go back into the atom. So, from previous studies, looking at the Bohr model of the atom consists of the components of electrons, which we know are now negative. We also have the which orbit the nucleus. We also have the nucleus, which from our previous internal you should be aware of, contains positive protons and neutral neutrons. And you can see those on the diagram right in the center. So overall, an atom has a charge which is neutral because the number of electrons equals the number of protons. So, is an object going to be charged? Well, the blue object, the number of positive charges equals the number of negative charges. Therefore, because the sum is going to be overall 0, we say that's uncharged. Whereas the pink object has 5 positive charges and 7 negative charges, therefore it is overall charged. Okay? Because the positive and negative charges balance in the blue object, and the positive and negative charges are unbalanced in the pink object. So, if an object or an atom gains electrons, it becomes negative, also known as an anion if it's an atom. And if an electron is removed from an atom or an object, it becomes positively charged, or in terms of atoms, a cation. So we can use this understanding of charged species, atoms, or objects to describe the following observations. Okay, so if you rub a comb in your hair and trying to pick up paper, you can see it picks up the paper. The same charged comb attracts water. And finally, this object here, I'm not sure what it is, picks up paper. So what's happening? Why is this happening? Well, this is all down to static electricity, also known as electrostatics. So electrical charges can build up in objects, like the comb, by rubbing them together, because the friction pulls electrons off objects, making them overall positive. This process is called static electricity because the charges stay on the object, they are stationary, okay, as opposed to currents and circuit electricity, which we will learn about later in the course. So, like magnets, electrical forces can repel or they can attract each other, and just like magnets, negative charges repel and positive and negative charges or like charges repel, and unlike charges attract, as you can see from the diagrams. So two negatives repel each other, two positives also repel each other, whereas a positive and negative are attracted to each other. Okay, now let's look at this animation. You can see the negatives repel and the positives repel. They're the same, whereas the two positive and negative combine. Okay. So what do we see in terms of charged objects interaction? Okay, so you've got any charged object, for this example, this positive balloon, will be attracted to an uncharged object. Twofold, because the electrons in the uncharged object will be attracted to the positive charge of the balloon, and correspondingly the positive charges in the uncharged object will be repelled by the positive charges in the balloon. Okay, so there's several everyday examples of this. If you brush your arm against the glowing screen of a TV set, you can feel the hairs on your arm begin to stand up because the electrons in the TV cathode ray tube are being attracting the electrons in your hair. When you take off your clothes off the dryer, or when you take off some clothes on dry days, you may notice a cracking noise because basically the clothes are ripping electrons off your skin, or conversely, the skin is ripping electrons off your clothes, and so therefore one is becoming positive, one is becoming overall negative, and then the electrons are moving across to neutralize the charge, and that's going to be your static spark. Okay, you may also have been zapped, the same principle there. And finally, people jumping off a trampoline experience a shock for the same reason, that negative charge is jumping towards that positive charge after positive charge is formed after friction has relieved the object of its electrons. So an example of that is the photocopier. It's an application of static electricity. As you can see from the diagram, you have a positive drum. The light shines on the paper. Obviously, if it's black, it's not going to shine through. So it means that the fine toner powder, which is negative, gets attracted to the area which has been black, because the light is able to pass through the paper and neutralize the positive charge, except for the area which is black, and therefore creating an image. And in further detail, you see it here. The photocopier uses static electricity, electrostatics, and the way they work is that you are copying an image of the page onto a charged plate, and then the light then causes the charge to leak away, leaving an electrostatic impression of the page. Then the charges left on the plate attract the small drops of black powder, remember, which are now negative. Okay, to the plate on the charges are left are positive, so it attracts a small negative ink, and the powder is transferred from the plate onto the paper, and the paper is then heated finally to fix the powder onto the paper. Okay, so an example of the power of static electricity is Stephen Gray's experiment. Okay, so Stephen Gray was an 18th century researcher. What he did was he suspended a small buoy from insulating ropes, so no charge could get into the ropes, into the buoy. And when he brought a large positively charged object near the buoy's feet, as you can see from the diagram, as I just mark it in, here we go. See, little positively charged object there. Okay, the buoy's nose picked up pieces of paper from a tabletop below. Okay, quite interesting. Okay, so the positive charge was being transferred to the buoy, and then because he was now overall positive, he was picking up the paper. Okay, the electrons were being attracted. Electrons in the paper were being attracted to the buoy's nose. Right, of course there are always dangers with static electricity, and a prime example is planes. Okay, during refueling, the fuel gains electrons from the pipe, making the pipe positive and the fuel negative. That ain't great, because there's a potential difference now. You've got a positive end and a negative end. This could cause the electrons to jump, as you see with static electricity on a hot day when you touch a door handle, and that would be bad news. So what you do is you either earth the fuel tank, which means you stick the fuel tank in the ground, so it means there's a whole lot of source of electrons from the earth, stopping that spark, because the electrons are positive charge attracted the electrons from the earth. Or you can use a copper rod or connect the tanker to a plane by the copper conductor, therefore completing the circuit. Okay, so that's enough today about static electricity. Next lesson will be on the Van de Graaff generator.